Hello learners, today we are going to learn LPP using MS Solver. Here LPP means linear programming problem, which is a mathematical model which helps us to take the better decision. Here we will study a case of Gunjan Sports Product Limited. It's a private limited company which manufactures two types of cricket balls. The first one is season ball and second one is tennis ball. To manufacture both the balls, it has to pass through a same assembly line, which has three different processes. The first process is cutting and dyeing, the second is stitching and assembling, and the third one is inspection and packaging. I will give a brief overview of a company. That company has established in 2013 and they are renowned in manufacturing sports equipment, specifically high quality cricket balls. The company has expanded its product line to various types of sports ball, but their main focus is on season and tennis balls. The company manufacturing unit is located in Pune, Maharashtra, with a dedicated workforce over 500 employees. Again, Gunjan Manufacturing Limited has pride of its manufacturing process and always meet the quality standards to the customer's expectation. The range of a product is much long season ball, tennis ball, rubber ball, even a magic ball. But yes, we will focus in this a season ball and tennis ball. So, season ball is used in a professional cricket match, and these balls are known for their durability and superior performance, whereas tennis balls are used for local matches or local tournaments and practice session, where the balls are bit softer and you can say normal match can be played. In manufacturing process, it has three different processes. The first is cutting and dyeing. So cutting and dyeing process involves cutting of raw leather or synthetic material into required shape and then dyeing them into specific color. The second part is stitching and assembling. In this stage, the cut pieces are stitched together to form the outer cell of a ball and core is then assembled inside the cell. And the third important thing is inspection and packaging. Each ball undergoes throughout inspection to ensure it the company meets to ensure the meets of the company's quality standard before packaging for distribution. There is also additional information. The first thing, for cutting and dyeing, a season ball takes 12 minutes and tennis ball takes 6 minutes. The total capacity is 20,400 minutes. Same way for stitching and assembly, season ball takes 9 minutes whereas tennis ball takes 15 minutes. The capacity is 25,200 minutes. For inspection and packaging, season ball and tennis ball both take 6 minutes and production capacity minutes is 12,000. Season balls can maximum produce 2000 units. Similarly, tennis ball can maximum produce 2000 units. Profit per unit for season ball is 50 rupees. Similarly, profit per tennis ball is 40 rupees. Market position. As we know, Gunjan Sports Products holds a significant market share in both tennis ball and season ball. But yes, we need to know that whether the company can have a long loyal customer base for years or for coming years. What is the objective of a company? So in this scenario, the company needs to get the optimal mix of season balls and tennis balls to maximize their profit. Basically, every company requires to maximize the profit. So the question is, how many season balls can be produced? How many tennis balls can be produced? And what would be the maximum level of a profit that can be achieved? To solve this kind of problem, we need to formulate mathematical problem known as LPP. So now this is an important slide we need to understand the structure of LPP. The first important thing is to define the decision variable. Which variable we need to decide? So in this scenario, we need to decide two important variables, or we need to decide on two important variables. The first one is season ball and second one is tennis balls. More important, what is our objective? So second step is to specify our objective constraint or to specify our objective. The third important thing is specify the constraints. As I always say in my class, resources are limited. In this scenario, the time is limited. So we need to set the constraints as per the requirement. And yes, non-zero constraint. In other words, we will see that everything can be zero but cannot be negative. So that we will discuss this when we will formulate the equation. So let's formulate step by step. The first step is define the decision variable. So I am just giving a name. Let x be the number of season balls to be produced and let y be the number of tennis balls to be produced. In simple terms, 1x or one ball of season would be represented by x. If I produce two balls, then 2x. Similarly, if I produce two tennis balls, then it would be represented by 2y. So I have just given a initials, x initial for season ball and y initial for tennis ball. Now the third thing, specify the objective function. I always say whenever you specify the function, you need to remember the z variable. So always remember whether maximize z or minimize z. So in this scenario, what is our objective? Our objective is to get more profit. So here we will write maximize profit is equal to 50x plus 40y because two decision variables are there. X is our season ball, y is our, you can say, tennis ball. So that's why maximize z is equal to 50x plus 40y. Now comes more important topic, that is constraints. So as we have seen all the things, first we need to remember what are the capacity or what are the things that are available. So first thing, for cutting and dyeing, we have maximum 20,400 minutes available. So here you will use less than or equal to constraint because maximum 20,400 minutes are available. You can use 20,400 minutes. Apart from that, you don't have a single minute. So here 12x plus 6y is less than equal to 20,400. Similarly for stitching, 9x plus 15y. See, I am adding both because my assembly line will manufacture both season ball as well as tennis ball. So 9x plus 15y is less than equal to 25,200. Similarly for inspection and packaging, 6x plus 6y less than equal to 12,000. So these are the basic constraint. Yes, one more thing. I can maximum produce 2000 a season ball and I can maximum produce 2000 a tennis ball. So X is less than equal to 2000 and yes, similarly Y is less than equal to 2000. So these are my constraint. Again, I am saying resources are limited. So same way we apply the same rules in production for formulating the constraints. The last point is non-zero constraint. Non-zero constraint means I can make zero season ball or I can make decide to make zero tennis ball, but I cannot have a negative thing. So that's why my x or y should be always greater than equal to zero. It can be zero, that is possible, but it cannot be negative, and that's why it's known as non-negative constraint, or you can say non-zero constraint. Okay, so now let's formulate this whole problem in Excel solver. So basically, if you don't have Excel solver, these are the for things that we need to open. So first, click on File, go to Options, go to Add-ins, go to Manage, go to Excel Add-ins, go to Add-ins Available, check Solver Add-in. If tick is not there, just tick that bar and just click OK. You can get your Excel solver. Yes, I will show in Excel also. So this is my Excel. Actually, I have solver, but yes, if you do not have this solver, go to File, go to Options, go to Add-ins, go to Excel Add-ins, and tick on Solver Add-in. You will get this kind of tab here in Dataribin. Now I have just written the same sum in Excel. So Gunjan Sports Limited, here the two decision variables are there, that is season ball and tennis ball. I have written X and Y. This are number of the variables I have just highlighted here. And yes, these are my constraint, that is cutting and dyeing, stitching and assembling, inspection and packaging. So I will just write here equal to this variable plus this variable, sorry, this variable multiply this variable plus this variable multiply this variable, because I want a value. So it's very simple. If I just write here one, if I'm making one season ball, it would give me 12 minutes. Same way, if I also make one season balls, it will make uh, 18 minutes. So now this is my decision variable. But yes, I can freeze the cell. So this both cell, just right, just click function F4 here. Similarly for C4, just click function and F4 to freeze these cells. Once the cells are freezed, you can see here the dollar signs comes. Once it is freezed, you just drag it till here. Same way, copy this same thing to our Z function. One more variable is there, maximum production, and two other constraints are there, but I am not taking here for the solution. I will take it in a later part. But now I am just opening MS Solver. I am just writing here a main, you can say, objective function. So obviously set objective, select this cell. Okay. Moving towards a decision variable, this yellow highlighted cell is my decision variable. And yes, add the constraint. So the first three constraints should be less than equal to this three constraints. Okay. Once it is added, you just cancel it, change the method to simplex, and just click on solve. You will get the answer here. This is my answer. This is my maximum profit, that is 94,000. I need to prepare 1400 season balls and 600 tennis balls to fulfill my best possible outcome. You can also see this in a graphical method. I have made a graph also. So you can see here 50x plus 40x2, that is equal to 94,000. So same way we can solve it. Yes, in Excel solver, you have one more option of uh, you can say getting all the things uh, in a simple way. So I hope you have learned the things. For any further query, you can comment in a chat box And my next video would be on, you can say, sensitivity analysis for the same sum. Stay with me. Thank you.